Here's another example. Let's say we have an investment, again, involving dollars and years. We have an investment of $4,000 at the beginning of some interval that grows to $5,600 at the end of the interval having a duration of 8 of these units, 8 years. Well, we just automatically calculate the rise in the area, and then we see how we might interpret each. So the rise is what? $5,600 minus $4,000, or $1,600. The run is clearly 8 years to the width of the triangle, or the trapezoid. And of course, it's always profitable to sketch this little triangle up here to be sure we keep track of what we mean by rise and run. The change in this quantity divided by the run, which is equal to this quantity. Rise being the change here, run being the width. Okay, the slope then is rise divided by run, $1,600 over 8 years, and that comes out in a very straightforward manner to $200 per year. Okay, well, now let's calculate the area. Very straightforward again. The average graph altitude, we add the two dollar amounts here and divide by 2. In other words, we add the two altitudes, divide by 2, and we get $4,800. The width is 8 years. So the area is $4,800 multiplied by 8 years. 4,800 times 8, if I did my arithmetic correctly, is $38,400. And I'm sorry, 38,400. Then the units are dollars times years. Dollars times years. Now, we can then attempt to interpret both of these quantities, and of course we want to label them in the graph. And I'm going to go ahead and do the labeling, then we'll talk quickly about the interpretation. Okay, so now we've labeled the $200 per year slope in the $38,400 times year area. Now, one quick caution. People will see dollars here and years here and automatically want to say dollars per year. This is not dollars per year. This is dollars per year. This makes sense as dollars per year in terms of the situation. This is dollars times years. It's not dollars per year. $38,400 per year has nothing at all to do with this situation. So we don't want to make the mistake of expressing dollars times years as dollars per year. Per means divided by, okay? Per involves division. This is not a division. Very, very common error and leads to all sorts of trouble and misinterpretations. So make sure you don't make that mistake. Okay, so first of all, $200 per year. What does that mean in terms of this thing? Well, we went up by $1,600 in 8 years, so that's an average of $200 per year. It's the average rate of change of the value of the investment with respect to clock time. Okay, so now I've written that in. What this means is the average rate at which the value changes with respect to clock time. Dividing the change in the number of dollars by the change in the clock time gives us the average rate of change, the average number of dollars per year. And in general, whenever you divide the change in graph altitude by the width or the run, you get the average rate of change of whatever this quantity is with respect to this quantity. Okay, now let's move on to the question of the area. What does $38,400 times years mean? See if you can come up with an interpretation. Well, hopefully you've given that some thought, and it's quite possible you couldn't come up with a good interpretation. And the reason for that might be, just coincidentally, that there is not a good interpretation. So I'm going to say there's no good interpretation in this case, as opposed to the preceding example where we have pay rate in dollars per year. When we calculated the area, we got something very tangible, the amount of money earned over that time. In this case, that's not so. And one reason for that is simply that this usually won't make any sense if the quantity measured in this direction is not a rate. Okay, writing that out, I say that area makes sense if the altitudes represent rates. WRT, and I use that down here also, stands for with respect to whatever the width quantity is. Now we'll see more about what that means, but that statement pretty much stands. Okay? Otherwise, areas usually don't make sense. So, in some cases they do, in some cases they don't. In the preceding example, the altitude quantity was rate of pay with respect to time. So many dollars per year. So when we multiplied that by a change in the amount of time, we got a number of dollars, the number of dollars earned. That's a case where the altitudes represent a rate, the rates with respect to the width quantity being time, clock time in both of these cases.